So good evening everyone. So here we will be discussing about redox reactions. In the last class we have solved some questions regarding how to calculate oxidation state, right now, and identifying species undergoing oxidation and reduction. Okay, so look at here, tell me your answer for this. What is the oxidation state of sulfur in this compound? Okay, how you will calculate that? By structure. If you calculate normally using the formula, what will be the answer? So if you take it as x, like 2 hydrogens are there, 2 into plus 1 plus x 5 into
minus 2 0.
So x will be minus 10 plus 2, so it will be plus 8 will be the value of x here. So but this is not possible now for sulfur. What is the maximum oxidation state possible for sulfur? So it can be 6. Okay, so in this case you will get the peroxy linkage. See, why peroxy linkage? Because here if this oxygen is in oxide form, it should be minus 2, but if I write it with peroxy bond, it will be minus 1 for each oxygen atom. Therefore if minus charge on oxygen decreasing means plus charge, that is oxidation state of sulfur, also decreases. So it means you can arrange that in this way, like this. How many oxygens are over? 3, 4 over, and 1 more here, like this. Okay, now you can calculate. So this will be minus 1, this will be minus 2, here it will be minus 1, this will be minus 2. Therefore what is the net positive charge here? If these 2 bonds taken by oxygen, it is minus 2, so it will be plus 2, this side plus 1, this side plus 2, and this side plus 1. So overall it will be plus 6. Sulfur is in plus 6 oxidation state in H2SO4. What is the name of that compound I told you? Chaos acid. Next, what about this compound?
Plus 6. Sorry, plus 4.
So how the structure looks? Plus
4.
Plus 6 only, here also. So if you normally calculate, how much you will get? 16 to, it means plus 7 you will get, but plus 7 is not possible now. So there also we have peroxy linkage. So like this will be the peroxy linkage. Why we are getting like that? See, already we have discussed how to draw the structures and all, and that's why I am writing directly. Tell me here, what is the oxidation state we have? 6 bonds are there around the sulfur with oxygen atom, so definitely it will be a plus 6. Okay, this side also plus 6, because all 6 bonds are dragging towards oxygen atoms only. Therefore each bond will be making it one as a plus 1. 6 bonds are there, so plus 6, like that. So plus 6 and plus 6. So now how many types of oxygens are there in this? See, between 2 sulfur atoms we have peroxy. These are of one type, and these are oxides like minus 2 now. So these are of another type. So we have 2 types of oxygens here, peroxides and oxides. Okay, next, what about oxidation state of chlorine in bleaching powder? So CaO. Oh, this one also is there. Okay, not seen. Okay, tell me. So plus 10 is not possible, because in the last class I told you how many valence electrons are there in chromium. Chromium, how many valence electrons? Atomic number 24. So it means 6 valence electrons are there. Okay, so 6 valence electrons means it can show maximum of plus 6. But if you calculate normally using the formula like x is equals x plus 5 into minus 2 equals to 0, if you do like this, you will get plus 10. See, this calculation normally we can say formula for calculating average oxidation states. Okay, but this is wrong here. Why it is wrong? Plus 10 is not possible on chromium. So now look at the structure. So you need to decrease that by 4 units. So it means you need to insert them as a peroxy linkages. See how I am doing. See, here 1 oxygen, 1 oxygen. Here also 1 more oxygen, 1 more oxygen. Between these 2 oxygens, we have a peroxy bond. Okay, 4 oxygens are over out of 5, one more it is there, I am writing it like this. So how it is looking? Like a butterfly now. So you can remember it as a butterfly structure, CrO5. Okay, so how much charge? So 6 bonds are there, all those bonds are with oxygen, so plus 6 for chromium, that's it. Okay, right, is this clear or not? Clear. Next, what about oxidation state of chlorine in bleaching powder? COCl2 is a formula you can take. See, we know calcium, alkali metals, that will be with always plus 2 charge. So remove this. So we have other part as minus 2 because Ca plus 2 I have written right now. So in these we have 2 chlorines now. So one chlorine which is having connection with this oxygen will be like this I am writing, and one more chlorine with like this. So it means one chlorine atom here is in -1 oxidation state, that is fine, but one more is there now here which is attached with the oxygen, that will be having what charge? See, this bond is dragging towards which side? Oxygen side, because it is more electronegative. So oxygen will be -2, the chlorine will be +1, because single bond now that will be taken by oxygen, means chlorine will be +1. So these are the individual oxidation state of all the elements present in this bleaching powder. Okay, so now what about chlorine? There will be -1 and +1, 2 types of oxidation states for chlorine atoms here in bleaching powder. Remember this. Okay, they will ask this kind of questions. Okay, next, look at this question, answer this. Already we did this question in the last class. What about this? This one also done, both. Then next, what about this question? Tell me fast. Identify the process in which change in oxidation state is 5. Number change should be 5, oxidation number change. Look properly. Once again. First of all you calculate individual like oxidation states this side. What is the oxidation state of this carbon in oxalate? What is this compound called? Oxalate ion, C2O4. So if you calculate, you will get +3. How much you will get? +3. How you will get? So 2x plus 4, each one has -2 charge oxygens, overall charge -2. So 2x will be -2 plus 6. So this will be plus, this is 8 plus 8. So it will be +6. Okay, so x will be 6/2, that will be 3. So +3 I am writing, that's why. Okay, what about carbon and carbon dioxide? +4. So what is the change? 3 to 4. This change is only 1, but they are asking for change should be 5. Here if you calculate, tell me. See, this is why we'll give in more number of questions in the exam, in class notes. Already you have did it for KMnO4. KMnO4 is nothing but permanganate only, na, potassium permanganate. I just removed that K place, remaining anion KMnO4, in that K removed. So MnO4 minus is there. So it means what is the oxidation state? +7. So you have calculated this. Okay, +7. And +7 converting into +2 means what? 5. So option 2. Very simple question. So you got how to calculate this manganese oxidation state. X you take plus 4 oxygens are there, 4 into -2 equals to total charge. Total charge present is -1 on it, equals to -1. Simplify, you will get +7. Next, what about this? Chromate, dichromate, you have did this one also. So why we will give examples in the notes while doing the class? Because if you do this already, it will be familiar when you are seeing in the questions. See, now you will be getting it as +6. Again, no need of calculation. The standard examples are there now. Try to remember them. So +6 is converting into +3. Means what is the change? Only 3. So only second option is perfect for this. Next, what about change here? It is also plus 6 converting into plus 3. Here also change will be 3. So only second option. Next, what about this? Oxidation states of phosphorus in these acids, oxo acids. 7 means 14, 14 means 4 you remove, 4 means 10 you are there, 10 it is there means divide by 2, so it will be plus 5. Next, here also 5 minus 10, 4 are there, so plus 6 means divide by 2 because 2 phosphorus are there, each one will be plus 3, that's it. Next, here 12, 12 minus 4 you do 8, 8 by 2 4 plus 4 will be the charge oxidation state. So option 4 will be your perfect answer. Easy only, without pen paper you can do these things. Okay, so what we discussed about range of oxidation numbers. So maximum oxidation state will be equals to number of valence electrons in it, whereas minimum oxidation number equals to electrons in the valence shell minus 8. For example, oxygen is having how many valence electrons? 6, and that valence electrons 6 minus 8, that is minimum will be minus 2. Minus 2. What is the maximum? Okay, now look at here. Look at here. I am taking one more example. Nitrogen I am taking. How many valence electrons are there?
5. Sorry.
Valence 5 electrons are there. So you should take 5 minus 8. So what is the minimum oxidation state possible? Minus 3. That's it. Maximum plus 5. Nitrogen with plus 5. Okay, clear now? Next. One more thing. Now there are two terms considered as oxidation. Wait. There are some two like new terms here you need to know. One is oxidizing agent, also called as oxidant. One more is reducing agent, reductant. These two terms are there here. So what do we mean by oxidizing agent? See, agent, what will that agent, like a person we are saying agents na, like normal in, that person will do some process. For example, travel agent means he will accompany us or he will make our traveling process easier. Right now, he will finish the ticket booking and all those things he will making it. Right now, here also oxidizing agent are those compounds which can oxidize others. It means this oxidizing agent will oxidize others and reduces themselves. Okay, so for example here KMnO4 is a good oxidizing agent. It means here it is in plus 7 oxidation state. Now whenever we are treating this with some oxalic acid or something like that, just now I told you what is oxalate ion formula, like this. Okay, so here what is the oxidation state of carbon here? Plus 3. So this permanganate having plus 7 oxidizes this oxalate ion to carbon dioxide. Now it is converting into plus 4. So what is this process here? Carbon is converting from plus 3 to plus 4 means it is carbon is undergoing oxidation. By how it is undergoing? With the help of this? So I can say KMnO4 is an oxidizing agent, oxidizing others, and now manganate, permanganate here converting into Mn plus 2 form. So plus 7 is converting into plus 2. So what is this? So this permanganate is undergoing reduction, means species undergoes reduction and oxidizes others. Okay, those species are considered as oxidizing agents. So these are the examples of oxidizing agents here. KMnO4, K2Cr2O7, HNO3, sulfuric acid, F2. These are some examples for oxidizing agents. Okay, and then next one more term is reducing agent. Now how can you define this reducing agent? Means
Which oxidize others and
which reduces others and oxidizes itself. So reducing agents are those compounds which can reduce others and oxidizes itself during a chemical reaction. So here we have Ki, like hypo, we can say Na2S2O3, lithium aluminium hydride, sodium borohydride. See, for example here I am taking for better understanding you consider this. What we have here? some formaldehyde we have. So to this I am adding lithium aluminium hydride. This is organic reaction, better you can understand very easily. Okay. So now what is the charge here you have? What is the oxidation state of this carbon? See, oxygens are there, this will be -2, carbon will be +2. Hydrogen carbon, which is more electronegative? Carbon. So hydrogen will be +1, this will be -1, this will be +1, this will be -1. What is the net charge present on the carbon? 0 here. Is this clear or not? Right. So this side it will become
Alcohol.
like this. So now what happening here? What is the oxidation state? Find here +1, +1, +1, and therefore it will be -1, -1, -1 three sides, and from above side this should be oxygen will be -1, carbon will be +1. So if these two numbers cancel, it is becoming -2. So 0 is converting into -2. So what is this transformation? Reduction. So reduction, this is a species making it to undergo reduction. So this species is called reducing agent. The species which reduces others are considered as reducing agent. Okay, right. Is this clear or not?
You can say that it adds hydrogen also. It adds hydrogen also.
Addition of hydrogen is what? Reduction only. That is what it is making here. Yeah. Or addition of electrons also? Reduction only. This can also be happen. Or removal of oxygen also? Reduction. Okay. So now one more thing here. Important points you can remember here itself. Important points for identification of oxidizing and reducing agent. How can we identify them? Someone in the comment box asking, sir, I want to start from 0. How to do it, sir? So just start from wherever you are, you just start from there right now. So if you initiate your process, you will get where you are first. Okay, whenever you feel you don't know something, you learn that. That's it. That is what we can say starting from 0. Nothing so special. Okay, right. Here an element is in its highest possible oxidation state in a compound. See, how can we identify? See, first point here, if you see an element, if it is in its highest oxidation state, then that will only act as oxidizing agent. That act only as oxidizing agent. Why? Because see, KMnO4 you have seen. In KMnO4, what is the oxidation state of manganese here? +7. So now if it is acting as oxidizing agent, now what it will do? It will oxidize others, reduces itself. Reduces itself means oxidation number will getting decreased. Like it might become Mn+6 or Mn+4 or Mn+2. Like this below numbers will be obtained by undergoing reduction. An oxidizing agent will oxidize others, reduces itself. So it will be reduces like this. So this will be seen, +6 will be seen in alkali medium. In which medium? Like basic medium. This is slight basic medium or neutral. This is acidic. These are the changes of KMnO4 in different mediums. If it is basic medium, converts into +6. If it is acid, slightly or neutral medium, +4. If it is strong like acidic medium, +2. So now what you are seeing? Oxidizing agent oxidizing others, this KMnO4 oxidizing others, reducing itself. See, now tell me, is there any higher number possible for manganese other than this +7? Greater than 7, is that possible? No, because valency electrons in manganese are 7 only. So maximum possibility is 7. So can I say, will it act as reducing agent, KMnO4? Reducing agent means what? It should reduces others, oxidizes itself. Will further oxidation is possible for undergoing oxidation is possible for manganese? No, because already it is in maximum oxidation state. Therefore, it cannot act as reducing agent. It can only act as oxidizing agents. So any species in its highest oxidation state can act as only oxidizing agent but not okay. Now similarly an element in its lowest possible oxidation state in a compound behaves as reducing agent. Okay, how it will behave? But not as oxidizing agent. If it is in its lowest oxidation state, further undergoing reduction is not possible now, further lowest number is not possible, already it is in lowest number. So that will only act as reducing agent but not as oxidizing. You got these 2 points? What are those 2 points? Any species in its highest oxidation state act as only oxidizing agent. Any species in its lowest oxidation state act as only reducing agent. Okay, that's it. Next. Now if an element is there in intermediate oxidation state, then that can show or that can undergo both oxidation as well as reduction. For example, I have nitrogen in +3 oxidation state. Now this nitrogen can undergo oxidation further to +5 till +5, or it can undergo reduction up to -3. We know up to -3 it can go. So it can go oxidation up to +1, something like that, reduction like this. So this is a species having intermediate oxidation state having both possibilities. Now it can act as both oxidizing agent, reducing agent. Okay, is this clear or not? Right. Okay, if an element is in intermediate oxidation state, then it can behave both as a reducing agent as well as oxidizing agent. See here, nitrous acid is given, HNO2. HNO2, what is the oxidation state here? +3. Now it can go up to +5 or come down up to -3. So it can act as both. Even hydrogen peroxide, H2O2 is there. So here its oxidation state is -1. So it can undergo oxidation till +2 or undergo reduction till -2. Right now. So it means H2O2 can act as both oxidizing as well as reducing. So look at here, there is, but mostly it will be here only, like this one. So here one thing you need to remember, H2O2 has ability to undergo show both reducing agent as well as oxidizing agent properties. Okay, depending upon the reactions it will vary its nature. Okay, next. If a highly electronegative element is in its higher oxidation state in a compound, then that compound can behave as a powerful oxidizing agent. Highly electronegative element means like chlorine, fluorine, we know it won't be in positive oxidation state. So we can say discuss about chlorine here. So chlorine here it is in +7 oxidation state. See, +7, here it is +3. Okay, here it is iodine. Okay, so here +7 +5 it is there. So you can see +7 is the highest highest oxidation state for chlorine now. Chlorine is electronegative element. See, already it is electronegative. What you know, electronegative element means it should requires electron, it will drag the electron, but it is in +7 oxidation state.
Electron deficiency.
Now it is having high tendency to drag the electrons, so it can easily accept the electrons. So that's why it is a powerful oxidizing agent. It will oxidizes others and reduces itself. Reducing itself means nothing but gaining. That is what it requires now. So I can say KClO4 can act as a strong oxidizing agent. Now between KClO4 and KClO3, which is strong oxidizing agent, tell me? The one which is having higher oxidation state can drag the electrons more easily now, accept the electrons more easily now, so it will be a stronger oxidizing agent. Is this clear or not? Right. Next, if an electronegative atom is in its lowest possible oxidation state in a compound or in a free state, it can behave as a powerful reducing agent like I minus Br minus like this. Okay, next. There are some types of reactions here, redox reaction. One is Important one is here disproportionation reaction. Disproportionation reaction means
Same element undergoing two different oxidation.
so same element simultaneously undergoing oxidation as well as reduction. See, redox reactions in which same element present in a particular compound in a definite oxidation state is oxidized as well as reduced. For example, H2O2 is there. Okay, so what is the oxidation state here?
-1.
So minus 1. Anyways, I have here examples. Na? See, H2O2 here we have that is undergoing like reduction as well as oxidation. So what is the oxidation state here you are seeing for H2O2? Calculate here.
-1
-1
plus
-2 0. So -1 to -2 it is reduction, -1 to 0 oxidation. So H2O2 oxygen having -1 oxidation state undergoing both reduction as well as oxidation. So we can say this as a disproportionation reaction. Okay. Similarly, what about the oxidation state of halogen here? X2 means halogen, you can say. Any element if it is combined with itself, it will be 0. Now OH I am taking in basic medium, this X2 taking in basic medium which is dilute solution. Okay, like dilute means dilute NaOH, like that I am taking. So now how it is converting? So X2 is converting into X minus, like halide ion. For example, if it is Cl2 gives OH minus, this is dilute OH minus. So it will give Cl chloride ion plus NaClO, like this. So what it is? See here we have ClO means ClO minus I can write. So here it is in +1 oxidation state. So what is the change you are seeing? From 0 to -1 and from 0 to +1. So same element undergoing oxidation as well as, so it is a disproportionation reaction. Same reaction I am taking, but here I am taking concentrated base. Okay, so now what happens here? X2 will be converting into X minus and further oxidation here it is something like ClO3 minus if I am taking chlorine. So what is the oxidation state? Remember, if it is dilute you will get +1, if it is concentrated you will get +5 oxidation state. Okay, these two things are remember. Okay, next here F2 is there. F2 does not undergo disproportionation reaction. Why it won't undergo disproportionation? Because it is most electronegative element. So fluorine will not show positive oxidation states. Will it show positive oxidation state? It will always either in 0 or in negative oxidation states like -1. Therefore, it won't undergo disproportionation reaction. Which one? F2. Okay, next here see, if you take F2, so it is F minus, here also it is F minus 1 only. So fluorine won't go, but here, yeah, that's it. Next you can see these reactions are important here. And these two reactions. These two. Okay. So here phosphorus, when any element combined with itself, what is the oxidation states? 0. So 0 converts into phosphine here. What is the oxidation state for P? -3 for phosphorus. Okay. And the next, here it is forming oxo acid. Okay. What is it? Salt of oxo acid here. So how much? O2 is there. O2 means -4, but here already -1 is there. So -3 here means +1 will be the oxidation state. Okay. So 0 to -3 reduction and this is oxidation. Okay. So what happening here? pH3 plus NaOH if we take, it will be P4 plus NaOH if we take, it will be giving us pH3 plus NaHPO2. 2. This kind of products are formed. Okay, so 0 converting into minus 3 to less 1. Okay, next. See, what is the oxidation state you are seeing here? Plus 6. Manganese in plus 6 oxidation state. Maximum oxidation state for manganese plus 7. So here it is plus 7 is formed. And here it is plus 4 it is formed. So this is also a disproportionation reaction. Next, comproportionation means
Reverse of disproportion.
reverse to disproportionation, you can say. Different oxidation states, here minus 3 and here minus means plus 3. Minus 3 plus 3, different oxidation states giving a product having same oxidation states. Then that is considered as comproportionation reaction, like reverse of disproportionation, you can remember. Okay, comproportionation reactions are reverse of disproportionation reactions. Next, balancing of redox reactions. Okay, so here we have two methods now in balancing of redox reaction: oxidation number method and
Ion electron.
method and ion electron method. Again, in this we need to do acidic reaction, balancing in acidic medium as well as in basic medium. So first of all we will start this oxidation number method with acidic medium, then followed by basic medium. Okay, here we will be taking example Cr2O7 minus 2 plus C2O4 minus 2 giving us Cr plus 3 plus CO2. So like this they will give the reaction, and they will say, sometimes they will say acidic medium, like this they will mention. Okay, so balance this redox reaction, they will say redox reaction. Okay, so here we are seeing H plus ion now, so it means it should be in acidic medium. So first of all what to do? First of all write this skeletal equation, whatever the equation they have given, assign their oxidation states. What is the oxidation state of chromium in this chromate, dichromate? Plus 6. Just now we did this. Plus 6. What about carbon in this oxalate? This is also I have told you. Plus 3. Here chromium converting into plus 3. What about here? Plus 4. Okay. So first of all what is the thing we need to do? Write the skeletal equation. After writing skeletal equation, write the skeletal equation. The next step is assign oxidation state. Okay, next identify species
Undergoing change in oxidation states.
Species oxidation, species undergoing oxidation and reduction. See, plus 6 is converting into plus 3. So what is this? Reduction. What about this thing? Carbon is undergoing plus 3 to plus 4 means oxidation. Okay, after writing this, now find number of electrons changing. What is the number of electrons changed here?
We should find corresponding coefficient to multiply.
How can you get that? See, plus okay. So plus 6 is converting into plus 3. So it means how many electrons? 3 electrons. How many chromiums are there here? 2 chromiums into 2. So total electrons are 6. For one chromium, 3 electrons. How many chromiums are there? So 2 3 is 6. So total 6 electrons are gained during the reaction. Now how many electrons in oxidation check here? See, 2 carbon atoms are there. Each one is converting from +3 to +4. So 1 electron lost. So it is 2. So remember, in a redox reaction, number of electron lost and gained should be equal. In order to equalize number of electrons, so what we need to do now? In order to equalize number of electrons, equalize total gain and loss in electrons by multiplying with a suitable integer. So what we can do that, tell me?
2 into 3, 6.
See, here already number is 6 in oxidation number, in reduction. Okay, in oxidation it is 2. So I can just multiply here with 3, therefore it becomes 6. I can multiply this with just 1, means I will keep it as it is. So what to do here? Chromium, I am writing Cr2O7 minus 2 plus
3.
this number is multiplied with, this equation is multiplied with 3. So it means 3 C2O4 minus 2 plus H plus gives rise to Cr plus 3 plus which number, what is the number? 3 CO. Like this we have to write. Okay, after writing this, balance
Elements other than oxygen and hydrogen.
balance all atoms other than H and O atoms. Okay, so how many chromiums are there here? 2. This side 1. So just we can balance just by multiplying with a number 2. Okay, that's it. Next, how many carbons are there here? 6. Here only
Here also 6. C3.
3. So I can just multiply with 2, so it becomes 6. Okay, so what it will be? So Cr2O7 minus 2 plus 3 C2O4 minus 2 plus H plus 2 Cr plus 3 plus 6 CO2. So all atoms are balanced other than oxygen and hydrogen. Now balance oxygen by adding water to deficient side of oxygen atoms. So where it is deficient, count here number of oxygen atoms. 7 plus 12. So 19 this side
and 12 that side.
12 this side. So what I can make? Cr2O7 2 minus plus 3 C2O4 minus 2 plus H plus 2 Cr plus 3 plus 6 CO2 plus 7 H2O. Now what about hydrogen atoms?
Add H plus ions on
Deficient, sir. So this side it is deficient now. So there are 14 H plus ions. So add direct H plus ion wherever it is deficient. So here this side now, so you can add 14 H plus. That's it. Equation is balanced. Okay. So it is clear now. So tell me the steps again. Once again. Write the little fast. Everyone. Everyone, write the skeletal equation. Assign the oxidation numbers. The next.
Identify the species undergoing reduction and oxidation.
Okay, the next.
Difference of electrons.
Find the number of electron lost and gained. Equalize those by multiplying with a suitable integer. Then balance all atoms other than oxygen and hydrogen. Then next, balance oxygens by adding water molecules wherever deficient. Then next, balance hydrogens by adding protons wherever deficient. Okay, now you can do this question. Do this fast. Fast, fast. Over. So already skeletal equation is given. Next what to do?
Oxidation state.
Oxidation state you can assign. After assigning the oxidation state, identify the species undergoing oxidation. Okay, and also identify the species undergoing reduction and oxidation. So this is undergoing oxidation. Okay, next number of electrons lost in oxidation, how many?
5.
Oxidation here
1. Oxidation 2.
like 2 into 2 carbons are there, each one is +1, converting into +4 means 2 electrons. In reduction it is
5.
1 manganese, converting +7 to +2 means 5. So 5 electrons. Okay, so equalize number of electrons lost and gain.
5 into 2, 10.
So very simple, you should multiply so why it will be wrong, just look at here. So here it is 5 electrons, here 2 electrons, but what we know, equalize these numbers. How can we equalize? Just multiply this number with here and this equation with other number. So this equation, reduction equation with 2 and oxidation equation with 5. Therefore you will get total electrons change as same, like 10 electrons and 10 electrons, that's it. So what is the final equation you will get? You are multiplying manganese 5 or 2 MnO4 minus giving 2 Mn plus 2, and then next what about oxalate ion equation, multiplying with 5. So 5 C2O4 2 minus giving 2 5s are 10, so 10 CO2 you are getting. And then next, what are the other things you require? Oxygens. How many oxygens are there here? 8 here and 20. So total 28 are there this side, and here also you require 28. How many are there? Only 20 oxygens are there. So just add 8 H2O. Hydrogens are how many required now? 16 hydrogens are required here. So plus 16 H plus ions reactant side. That's it. Where do we have?
So option 2.
So 2, 5, 16. That's it. Second option. Okay. So practice 1 or 2 questions. You will get. Next, we'll do balancing in basic medium now. Okay, so for that I am taking Cr OH trice plus IO3 minus giving Cr plus CrO4 minus 2 plus I minus. So tell me.
Plus 3 Cr oxidation state.
Tell me. So first of all, write the equation, done. Next,
Plus 3
assign the oxidation states, minus 1. So this is what? Minus 3 to plus 3 to plus 6. Oxidation. So how much number it is?
3.
3 into 1 chromium. So 3. And from here to here, plus 5 to minus 1, 6. Total iodide atoms are, iodine atoms are 1 only, so
2 Cr
6.
OH.
So what we should make? This equation should be multiplied with
2.
2. This equation should be
1.
kept as it is. So what I should make here? 2 CrOH taken twice plus 1 IO3 minus gives 2 CrO4 minus 2 plus I minus. Okay, so look at here, chromium atoms are balanced or not? Balanced. Next, iodine also balanced. Now next remaining is oxygen. So oxygens, how many are there this side? 6 plus 3. 9 oxygen atoms this side. Here only 8 are there. So what I should make here? Add 1 H2O. Wherever it is deficient, there you add water. Okay. Then next, what we need to do? This is basic medium now. In which medium I am saying? Basic medium. So add, we need to balance what? Hydrogens we need to balance. Now carefully you can look here. Wherever deficient in hydrogen, that side you add H2O. Opposite side add OH minus with equal number. What you balanced here up till here? Water molecules you added to balance oxygen atoms. Oxygen atoms are balanced now. Now count hydrogen atoms, how many are there this side? 2, 3s are 6 hydrogen atoms are there this side. But there we have 2 hydrogen atoms. So what to do now? Add OH minus to the deficient, add water molecule to the deficient side of hydrogens, where it is deficient.
Or we can add OH on both sides.
Wait. This is the best method you can see. Add water molecules wherever deficient in hydrogens. So how many deficient this side? 6 are there this side. These are 2 are there. So still 4 are required. Okay. So 4 hydrogens means I can make 2 H2. Okay. This side what I should add?
OH.
How many?
Same number.
Whatever the number you have added that side. Okay. Now rewrite the equation. Cr OH trice plus IO3 minus gives rise to 2 CrO4 2 minus plus I minus plus 3 H2O. Try to count number of oxygens and hydrogens again. 2 3 is 6. Okay. So what is missing here?
2 OH.
It's 2 OH minus. So now just count now how they are.
6 oxygens, 9, 11 oxygens this side, 8.
1 minute.
oxygens that side.
Once again we'll come back here. So just look at here, how many hydrogens are there? 6 are there. So 6. This side how many oxygen hydrogens are there?
8.
initially 2 are there, like this. Okay, now how many are required?
6.
Huh.
4 are
4 are required. So add, how many hydrogens are less this side? 4 are less. Add that many number of water molecules here. Equal number of OH minus this side. Okay, now it is clear? Right. Now make it 2 CrOH twice plus IO3 minus plus 4 OH minus gives 2 CrO4 minus 2 plus I minus plus 5 H2. Now count.
10, 4 plus 3, 9.
So what is the method, that is what we need to do for balancing?
First we should balance hydrogen, then
Balancing hydrogen atoms.
add
Add
that means number of H2O.
add required number of H2O to the deficient side and same number of OH minus ions to the opposite side. That's it. This is the equation, this is the statement you should follow every time when you are balancing hydrogen atoms in basic medium. Is this clear or not? Right. Write this. So only difference is at this statement, remaining every step is same. Next, solve these questions. All these are very basic questions but appeared in NEET exam. So yeah, look at this. What's your answer for that? Which of the following reactions are disproportionation? So what to do? Assign their oxidation states, +1 converting into +2 and 0. So this is a disproportionation. Here it is +6 converting into +7 and +4. We already seen this example. This is also a disproportionation. What about this +7? So maximum already manganate ion, permanganate ion, manganese in maximum. So it won't undergo disproportionation. No need of doing that. Again here look at this. This is +7. This is +2 converting into +4. This is comproportionation reaction, reverse of disproportionation. So only A, B. So where do we have? First option. Okay, right. Next, this one. Not a redox reaction. See, identify +2, here also +2, here +6, sulfur is also +6. This is not a redox reaction. Next, zinc, here it is 0 converting into +2, so it is undergoing oxidation, and copper +2 converting into 0. This is a redox reaction. So not a redox means first option. Next, +5 converting into 0, 0 converting into +5. So this is a redox. Next, what about this 0, 0 converting into +1 and -1? That is also a redox. So option 1. That's it. Next. Ante ante. Correct order of nitrogen atoms in decreasing order of their oxidation states. Just calculate and tell me.
Option
Option 1.
Option
Wait.
no.
N2, N2O, last is NO. Sorry, plus 2.
Hmm. Lock. See, nitric acid
Plus 1.
plus 5. What about this?
Minus 2. Sorry, plus 2.
Plus 2. This one is 0. Here it is minus 3. So, what they are asking? Which order? Decreasing order. So, this is decreasing only now. So, next. This one? Done. This one? What is the change in oxidation number of carbon in the following reaction?
Plus 4 2.
Carbon, hydrogen, which is more electronegative? Carbon, na? So minus 4 for carbon. Okay, it is 0 and here it is plus 4. What they are asking, change in oxidation number.
Minus 4 to plus 4. Option.
So how much it is? Minus 4 to plus 4. So option 2. Next, second question, next question. Iodide ion is there na? I minus in neutral or alkaline medium converts into IO3 minus. Okay, so what they are asking? Neutral or faintly alkaline medium, Kmin for oxidized iodide ion to iodate. Okay, the change in oxidation number
Plus 4.
of manganese. So manganese faintly alkaline means what I told you? Faintly alkaline or neutral.
Plus 6.
Plus 7 to KMnO4, I told you MnO4 minus converts into MnO2. It means plus 4. See, I told you three things. One is
Strongly alkaline.
MnO4 minus permanganate ion MnO4 minus in three things. One is basic,
Slightly alkaline or neutral.
slightly alkaline or neutral. This is what they are asking, right? In the question. And the next, acidic. So what I told you, Mn plus 7 converts into Mn plus 6 in basic.
Plus 4.
In neutral or slightly alkaline, plus 4. So plus 4 is nothing but MnO2 type of compounds. Okay? And the next,
Plus 2.
Mn plus 2. So Mn plus 2 like MnCl2 kind of compounds might be formed during the reaction depending upon what type of things involving there. Okay? So it is what?
Fourth option.
Plus 7 to
Plus 4.
plus 4 because they are asking in neutral or slightly alkaline medium. So fourth. Okay, clear now? Any confusions or any doubts? Yes. If no doubts, we will wind up this session. Okay. Those who are watching in live, if you are new to this channel, please click on the subscribe button and you can write your questions or your queries in the comment box. Okay. Thank you for watching.